Derivatives of inverse functions. Recall the definition of an inverse function. We say that f and f inverse are invertible if the f inverse of f of x is equal to f of f inverse of x, which is equal to x. Also, if f and f inverse are invertible, then f of a is equal to b and f inverse of b is equal to a. For example, the inverse of f of x is equal to 4x is f inverse of x, which is equal to x divided by 4. Once you know the inverse of f of x is equal to 4x is f inverse of x is equal to x divided by 4, you can differentiate it to find the derivative of the inverse of f of x. Using the power rule, we would get the derivative of f inverse of x is equal to 1/4. It's important to note that as you work through the following problems, it is extremely important to pay close attention to the notation. A common error is to forget and/or mix up the inverse sign and the derivative sign. Please note the differences. F prime of x has the f apostrophe and then x in parentheses. The inverse of f, or f inverse, is noted as f raised to the -1 power of x, and the derivative of the inverse is noted as f raised to the -1, the prime notation, and then x in parentheses. If you can find the inverse of the function quickly and then differentiate, do so. If not, there is a formula that can be memorized and used consistently. Let's start with a fact about inverse functions. We know that f of f inverse of x is equal to x. Then we derive both sides of this equation by applying the chain rule on the left and the power rule on the right. So f prime of f inverse of x times the derivative of f inverse of x is equal to 1. Divide to isolate the derivative of f inverse of x. Therefore, the derivative of the inverse of any function is 1 divided by f prime of f inverse of x. It's important to note that we can recall the formula below if finding the inverse of the function is not easily done. This formula will work for all functions except trigonometric functions. The derivatives of inverse trigonometric functions need to be memorized. And here is a chart of all the derivatives of inverse trigonometric functions. Keep these handy as you work through these types of problems. And these problems typically appear on the multiple choice section of the exam. Let's try an example. If f of 3 is equal to 5 and f prime of 3 is equal to 7, find the derivative of f inverse of 5. The first step is to find f inverse of 5 by switching the x and y values. So if f of 3 is equal to 5, then f inverse of 5 is equal to 3. The next step is to set up the derivative of the inverse formula. So the derivative of f inverse of 5 is equal to 1 divided by f prime of the inverse of f of 5. The next step is to substitute f inverse of 5 is equal to 3 into our function. So we have, or into our formula, so now we have 1 divided by f prime of 3, because we know that the inverse of f of 5 is 3. So literally substitute that in for this term. And now we're ready for the next step, which is to substitute 7 in for f prime of 3, because we're given that value. Therefore, now let's try to find the derivative of the inverse of y is equal to x to the third. Begin by finding the inverse of y. So we know that y is equal to x cubed, so we switch our x and y values and write it as x is equal to y cubed. And then we solve by taking the cube root of both sides, and we get that the inverse of y is equal to the cubed root of x. Next, we can find the derivative of y inverse using the power rule. We know that y inverse can also be written as x to the 1/3 power. So now we can use this power rule to find the derivative. So we would bring the 1/3 down and raise x to the negative 2/3 power by the power rule. And we'll have that y inverse is equal to 1 divided by 3 times the cubed root of x squared. Let's try another example. Suppose f of 1 is equal to 9, and f prime of x is equal to the quantity x squared plus 5 divided by the quantity 7x squared plus 17. Find the derivative of f inverse of 9. Since we know that f of 1 is equal to 9, we can find f inverse of 9 by switching the x and y values around. Next, set up the derivative of inverses formula. So the derivative of f inverse of 9 is equal to 1 divided by f prime of f inverse of 9. The last step is to substitute the values accordingly and simplify. We know that f inverse of 9 is equal to 1, so we can fill 1 into this set of parentheses. And now we're doing 1 divided by f prime of 1. Well, we know what f prime of x is, so let's substitute 1 in for the x values and simplify. So we have 1 divided by 1 plus 5 divided by 7 plus 17. So that's 6 divided by 24. So that's 1 over 1/4, which is equal to 4.